Hi everyone, Rhoda here with the Jack Capsule about trigonometry. We're going to talk about the relationship between the graphs of sine and cosine. Here they are both plotted together. So first things first, which one is which? Do you know which is sine and which one is cosine? Stop and think about that for a second. I'll tell you the answer. Y equals sine of x is my blue graph. Y equals cosine of x is my purple graph. Now let's take a look at these. What can we notice? They really have the same shape as each other. It kind of looks like the two graphs are the same, except one starts a little bit ahead of the other one or vice versa. There's some kind of shift happening. So it's really helpful if you understand what that shift actually is. To understand what it is, we could take some examples, look at some specific points. So let's say if I look at x equals 0. At x equals 0, my sine graph is at y equals 0, and my cosine graph is at y equals 1. Well, let me go back to that point 0, 0 for sine. So my sine graph is at y equals 0 when x is equal to 0. When does that same point occur for the cosine graph? I'm looking for where's the nearest point on my purple function that is having the same behavior. That would be over here at negative pi on 2. Because at negative pi on 2, cosine is doing the exact same thing. It's crossing through the x-axis and going up. So what I could see is that these pictures are really the same, except with a shift of pi on 2. You could see that again by looking at another point. So if I go back to my point 1, 0, if I look at cosine, when x equals 0, I'm up here. And I could ask myself, when does that same point happen for sine? When is sine doing the same thing? So when is sine at the top of its peak? The nearest place where that happens is right here. That's at x equals pi over 2, y equals 1. So again, I'm seeing that there's a shift happening with a distance of pi over 2. So you could really think that these graphs are the same, except one is ahead of the other by pi over 2, or you could think of it as one is behind the other by pi over 2. How can we write that down as a formula? That would be really useful in certain applications. I'm going to write it down in two different ways. First of all, in terms of sine. So sine of x equals cosine of what? Let's take an example. If I wanted to know what's sine of 0, where could I look on the cosine function to get the same answer? So if I wanted to know what's sine of 0, but I wanted to get that by looking at cosine, which x value for cosine would I use? I would use negative pi over 2. So instead of using my x value of 0, I would have to use my x value of 0 minus pi over 2, and then I would get the same answer. Or let me think about it the other way around. Cosine of x equals sine of what? So if I wanted to get a cosine value, let's say, for example, I wanted to know what's cosine of 0, where would I look on the sine function to get the same answer? I would have to look over here at pi over 2. So cosine of 0 is the same as sine of 0 plus pi over 2. These equations here let you go back and forth between sine and cosine, and they're what we call a phase shift. And if you know about this phase shift, then when you get to more complicated functions like tan and cotan, secant and cosecant, you can use that knowledge to also understand their graphs as well. For more about those graphs, you can move on to the next video.